So now what about a negative integer? And again, I just prepped you for this a little bit. You saw what happened. I took that c to the negative 2 and I popped it down to the denominator and lost the negative exponent. And that's the definition of what to do with a negative integer exponent. As long as it's not 0 and p is a counting number, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, so on, going on to forever, then b to the negative p is equal to 1 over b to the positive p. You change the sign and you move it, right? So it was in the numerator technically because anything is over 1, and then you switch it so that it's under 1. In other words, you take the reciprocal and you switch the sign. Okay, so let's do it. So the first one I have here is 4 to the negative 2. I can speak. Okay, so what is that? That means that we have to make it equal to 1 over 4 to the positive 2. You flip it and then you get rid of the sign, which is 1 over 16, because you're not allowed to leave powers. In order to be truly simplified, you have to find any numbers that are possible. Okay, what about the next one? Well, that's kind of easy. That's b to the negative 7. I mean, that basically is the formula, right? So it's 1 over b to the 7, which is equal to 1 over b to 7. Actually, there's nothing to do there, right? There's no number to simplify. There's none of that. You know, for the heck of it, let me throw in another example here. Hold on one second. There we go. All right, so let me make up one. What if it had been, for the sake of it, 4 to the negative 2, b to the negative 7? Well, then all you do is flip both of them. So you say, oh, okay, that's 1 over 4 to the 2, b to the 7, which is 1 over 16, b to the 7, like that. Okay, so throw that extra example in there just so you can see what happens when they're both like that. Although, here. All right, now what about the true c, the original third example, 3 times x to the negative 4? Well, I wanted you to see this example that I just threw in there because it's different from this one. See, on the one I just did, the 4 was to a negative power. That's why the 4 went down. But if you look at the one we have currently, 3 is not to a negative power. 3 is still just sitting there, right? What has the negative power is the x to the 4th. So the x, if you line it in parentheses, you can do that. That's fine. But it's x to the 4 goes down and he loses his negative power. It sounds like a sorcerer. He lost his negative power. Or maybe Anakin Skywalker or something, right? But it loses the negative in front of that exponent. But the 3 never had a negative exponent. The 3 was just 3, right? I mean, if you like, what you could say is that original problem is 3 times x to the negative 4. There's no even need for the parentheses, to be honest with you. They're just there, right? But this is that original problem. So really only the x goes down and the 3 just sits there. And you're done because there's nothing to simplify on that. That's it. Okay, so now what happens if it's in the denominator? So this was b to the negative p in the numerator. What happens if your negative power is in the denominator? Well, it doesn't really change it. So if it was in the numerator, you flip it to the denominator. If it's in the denominator, you flip it to the numerator and lose the negative in front of that exponent again. Lose that negative power. You don't know the power of the negative power. All right, never mind. I'm done with the Darth Vader reference. Okay, so to find 1 over b to the negative p, you take its reciprocal and switch the sign. It's the same rule. So let's look at this one. 1 over 4 to the negative 3. Like that. Okay, so, well, let's see. My negative power is in my denominator. So I'm going to flip it and make it equal to 4 to the 3 over 1. Which is, let's see, 64 over 1, which we never write anything over 1. We're math people, so we're lazy, so we're just going to write 64. All right, now what about b? It was 1 over b to the 9, so it's equal to b to the positive 9 now. You lose your negative over 1. Which we again would just write b to the 9. Nobody ever bothers writing things over 1 because it's notationally annoying. I mean, seriously, that's the reason for it. It's not elegant, as my math professors would say, and they're right. It isn't. All right, now what about C? Okay, so C is a little bit different than A and B. So C is actually kind of closest to A, but C's got a bit of an issue because who has the negative power on this one? Right? It's 3 times 2 to the negative third. So that negative third is only really affecting the 2. See it? So then what you're going to do is you're going to say, okay, I'm going to move the 2 up, lose the negative in front of that exponent. But this 3, I'm just going to leave it down there because he didn't have a negative power. He doesn't get to move, which means it's 8 over 3. Done. All right, what if they're both negative? Well, then what do you do? Good question. Okay, so if you have b to the negative 5 over b to the negative 2, you flip both of them. Okay, so b to the negative 5 was on top. You move it to the bottom and write b to the positive 5. You lose the sign. So you make the reciprocal and change the sign. Switch the sign. B to the negative 2 was on bottom, so now you put it on the numerator and get rid of the negative there. Now, unfortunately for you, you are not done. You have to simplify this a bit. So this is b to the 2 take away 5, which is b to the negative 3. But you're not allowed to leave a negative exponent. That's not simplified, so you've got to write 1 over b to the 3. Now, some students don't really like the subtraction method because it requires this kind of extra step. So they just want to kind of look at it and go, oh, wait, I have 2 b's up here, 5 b's down here. I divide and leaves me 3 left over in the denominator. That's a-okay as long as your powers are positive. Where students get into trouble is they'll start trying to use that technique when they're both negative, and that will not work, right? Because people don't do the subtractions with the negatives correctly, etc., etc. So if you want to think of it as canceling, which is a terrible term, it's really more division. If you want to think of it that way, then that's fine, but make it so the powers are positive. If you never want to go wrong, then just use the subtraction property. The whole, it's 2 take away 5, that's a negative, that means it's in the denominator. It may be one more step, but you won't be incorrect with it. Personally, I do both. All right. We will not be able to finish this next page, but we can at least get started. So just a reminder up here in this box of what it takes to be simplified. No parentheses, no double variables, write every number as a number, and no negative exponents. Every exponent's got to be positive, period. All right, so example A is really very similar to the one we just did, but actually easier. So this is not going to be hard at all. All you got to do is, all you have to do, I know, English teachers out there are cringing. All right, so you move the C not X, C up and the B down. And that's it. Nothing cancels, nothing simplifies. I mean, it's actually a simpler problem than the one that we just saw right here, where since they were both B's and this one, you had to kind of finish it out and subtract and stuff. But here, since they're not like terms, you can't even do anything after that. You're done. All right, they'll all stay that easy. Just kidding, they won't. All right, so let's look at letter B. Okay, so this is really, now notice again, this is kind of a weird trick that mathematicians like to do to you, and I'm sorry, but that's just how it is. So they tend to write things with parentheses sometimes when they don't have to, primarily because they prefer that notation to the dot notation. Dots with negatives has got its own issues. A lot of people lose the negative, they lose the dot, they forget what they're doing, etc. But in this particular problem, there was no point to those parentheses. Those parentheses were just there for multiplication, right? So you could have just written it all with a dot and you'd be fine. Now, why am I doing that? Well, because that helps us rearrange things. You say, look, if that, look at, just for a second, look at D. Now there's a parenthesis you can't get rid of as easily because it's got that power outside like that. But the one on B doesn't have any powers outside. It's a simpler problem than that, right? So there was no point to those parentheses in the first place other than multiplication. They were just a symbol to show multiplication. So that means you don't need them at all, and you can just rearrange things like you want. So I'm going to rearrange them in order. I got the two numbers in front, I got the B's next, and I got the C's next. Now the numbers are the easy part. 6 times negative 2 makes negative 12. No problem. Now the B's. What is this? When you have b to the negative 9 times b to the 5, that's b to the negative 9 plus 5. You add them. And c to the 4 plus negative 3, or if you like, 4 minus 3. Right? You add those powers. It's the first rule of exponents. Back here, several pages on page 66. First rule of exponents, right there. B to the negative 9 times b to the 5 means b to the negative 9 plus 5. Boom. That's where I'm getting that from, right there. It's almost identical to the instructions on that rule of property, or property of exponent rule. All right, so negative 12, cool. B to the, now negative 9 plus 5 is negative 4. C to the 1. Now, anything with a negative exponent is not allowed. So you've got to move this b to the negative 4 part to the denominator. Now, you might be wondering what to do about the negative 12. And the answer is nothing. Right? See, the negative 12 is not a power. Only the negative powers move down to the denominator. But negative numbers just sit where they are. And of course, we never bother with writing an exponent of 1 because it's annoying. We're lazy, so we will just write C. And then the 12 stays there because it's just a negative 12, that's fine. But the b to the 4 is a negative power. Negative powers go to the denominators. Done with that one. Right? There's no parentheses, no letters written more than once, and no negative powers. You can have negative numbers, negative 12, that's fine, but no negative powers. And we've got time for C. Let's do it. So this is equal to, now, you can do this a lot of ways. First thing you want to notice is you've got 18 over 27. B to the, okay, now what do you do with powers this way? It's negative 5, take away 5, take away 3. I'm using that subtraction property from page 66 right here. Number 2. B to the negative 5 on top, positive 3 on bottom, made b to the negative 5 take away 3. Like that. All right, then with the C's, let me scroll back down. Oops, not too far, hold on. There we go. So that's C to the negative 4 take away negative 6. Double negative. Ooh. Okay. Now we both know, hopefully, you and me and everybody else watching knows that 9 goes into 18 2 times, 9 goes into 18 3 times. There, that's done. B to the negative 8, and then C to the, okay, it's negative 4 plus 6, right? Because it's minus a minus 6. And negative 4 plus 6 is 2. And then you write equals 2C squared, because those two are both positive, and then 3, because it's in the denominator, b to the 8, because you're not allowed to leave this guy with the negative 8 exponent. He's got to go. You got to make him a positive exponent. 2 is in the numerator. C squared is in the numerator because it's a positive. B to the 8th has a negative power, so he goes down, and 3 is already down there. I will have to finish the next problem on the next video, and then we'll do scientific notation. I'll see you then.